Assalamu alaikum. My name is Zainab Haroon and my topics to represent are estimation of parameters, their interpretations, R and R square. First of all, we have to define alpha and beta. We assume that the linear relationship between the dependent variable y iota and the value of x iota of the regressor axis y iota is equals to alpha plus beta x iota plus e iota, where the x iotas are fixed. The y iotas are observations randomly drawn from a population. The e iotas are error components deviation, where alpha and beta are population parameters. Alpha is the intercept and the slope, beta is called regression coefficient, which may be positive or negative depending on the direction of the relationship between x and y. So the next topic is coefficient of determination. The coefficient of determination, which measure the proportion of variability of the values of the dependent variable y explained by its linear relation with the independent variable x, is defined by the ratio of the explained variation to the total variation. It is denoted by r square. For example, a value of r square is equals to 0.93 indicates that 93% of the variability in y is explained by its linear relationship with the independent variable x. Simply, we can say that r square measures a proportion of variability independent variable due to linear relationship with independent variable. Let's solve a question from the exercise. So, question number 10.11 part B. Here I write the commands: analyze regression, linear dependent y, independent x, statistics, model fit, estimate, r square change, and then OK. So, here I put the data in x and y respectively, and then analyze regression and then linear. So we put y in dependent and x in independent, and then statistics, and then we got the options of estimate, model fit, and r square change. Continue and then OK. So we have the answer of r square is 0.351, which is 0.351. So interpretation is the variability in that dependent variable y due to independent variable x is 0.351. So next topic is correlation, which is denoted by R. Correlation, like covariance, is a measure of the degree to which any two variables vary together. In other words, two variables are said to be correlated if they tend to simultaneously vary in some direction. If both the variables tend to increase or decrease together, the correlation is said to be direct or positive. For example, the length of an iron bar will increase as the temperature increases. If one variable tends to increase as the other variable decreases, the correlation is said to be negative or inverse. For example, the volume of gas will decrease as the pressure increases. It is worth remarking that in correlation we assess the strength of the relationship between two variables. Both the variables are random variables and they are treated symmetrically. That is, there is no distinction between dependent and independent variable. R lies between -1 and 1. Let's solve the question from exercise. Question number 10.20. Calculate the coefficient of correlation. The commands are same as coefficient of determination. We put the data x and y respectively, and then analyze regression, linear, and then estimates or model fit. Here we don't put the cursor in r squared change. Continue, and we got the answer 0.967, which is 0.98. So the value of r is 0.98, and we can say that it is a strong relationship. I forgot to mention in recent slides, if r is equals to 1 or near than 1, then it is a perfect relationship. If r is equals to 0.75 or near, then it is a strong relationship. If R is equals to 0.5 or near than 0.5, then it is a medium correlation, and if R is equals to 0.25, then it is a weak relationship. Thank you.